This video is about solving system of linear equations using Gaussian elimination method. Example 1. Checking solutions. Determine whether -1, -4, 5 is a solution of the following system of equations. So here we have equations x minus 2y plus 3z equal to 22 and 2x minus 3y minus z equals to 5 and 3x plus y minus 5z equals to minus 32. So let's check if -1, -4, 5 is a solution to equation number 1. So we're going to replace -1 for x and -4 for y and 5 for z in equation 1. So we have -1 times -2 times -4 plus 3 times 5 equals to 22. Now we simplify the left side, so we -1, -2 times -4 plus 8, 3 times 5 is 15 equals 22. Now 15 plus 8, 23 minus 1, 22. So we have a 22 equals 22, which is true. So this says that -1, -4, 5 is a solution to equation number 1. So now we're going to replace -1 for x, -4 for y, and 5 for z in equation number 2, which is 2x minus 3y minus z equals to 5. So this equation becomes 2 times -1 minus 3 times -4, and z is 5, so it'll be minus 5 equals to 5. Now I simplify, so it'll be 2 times -1 is -2, and -3 times -4 will be 12, and minus 5. So it looks like minus 2 plus 12 is plus 10, and 10 minus 5 is 5. So we have 5 equals to 5, which is true again. So that means -1, -4, and 5 is also a solution to equation number 2. Number 3. Now we replace -1 for x, -4 for y, and 5 for z in equation number 3, which is 3x plus y minus 5z equal to minus 32. So this becomes 3 times -1 plus -4 minus 5 times z is 5 equals to minus 32. So simplify, 3 times -1 is -3, plus minus 4 is -4, and minus 5 times 5 is minus 25 equals to -32. Now minus 3 subtract 4 be -7, subtract 25 be -32. So now we have a -32 equals to -32, which is true. So this means that -1 and -4 and 5 is also solution to equation 3. So since -1, -4, and 5 is the solution to equation number 1, equation number 2, and equation number 3, so we can make conclusion that the order triple -1, -4, 5 is a solution to the system. And so the answer is yes. Row echelon form of system of equation. System is in row echelon form if it has a stair-step pattern with leading coefficients 1. So just like this one, first stair and then up and then up, and say this is the leading coefficient 1, leading coefficient 1, and leading coefficient 1. So this system is in row echelon form. Example 2. So you say use the back substitution to solve this system of linear equation in row echelon form. So we have a first equation x minus 5 plus 5 is equal to 32, y plus 2 is equal to 6, and z is equal to 8. So we're going to start with the last equation. So we're going to substitute z is equal to 8 in the previous equation number 2. So this becomes y plus 2 times 8 equals to 6, and then 2 times 8 is 16, so we have y plus 16 equals 6. We move the 16 to the right, it becomes y equals 6 minus 16, which is negative 10. So y is negative 10, we already know z is 8. Now we substitute z is equal to 8, y is equal to negative 10 in equation number 1. So the equation becomes x minus and y is negative 10 plus 5 times z, and z is 8 and equals to 32. Now we simplify, it becomes x minus 10 becomes x plus 10, 5 plus 8 40, so we have x plus 10 plus 40 equals 32. Now 10 plus 40 is 50, so we have x plus 50 equals 32. Now we move the 50 to the right side, and we have x equal to 32 minus 15, which is minus 15. So now we put all the answers together. So x is minus 18, y is negative 10, and z is 8, and that's the solution to the system. Gaussian Elimination Method to solve system of equation 3 variables. So step 1, write the equation in standard form. Ax plus by plus cz equal to d. In other words, all the variable terms on the left side and the right side has to be constant. Now we rewrite this system in a row echelon form, and then step 3, do back substitution to find the values of the variables. So here is an example 3. Solve the system of linear equations and check any solutions algebraically. So you have an equation x minus y plus 3z is equal to 8, 3x plus y minus 2z is equal to minus 2, 2x plus 4y plus z equals to 0. So step 1, make sure all the equations standard form. So we rewrote the equation x minus y plus 3 is equal to 8, 3y plus y, 3x plus y minus 2 is equal to negative 2, equation 2, 2x plus 4y plus z equals to equation 3. So now we're going to rewrite this system in row echelon form. Note that the leading coefficient number part of x in equation 1 is 1. So we begin by keeping the x in the upper left position and eliminate the other x terms like 3x and 2x respectively from the first column. How? So to eliminate 3x in equation 2, we multiply equation 1 by minus 3 and then add into equation 2. So here we have minus 3 times equation 1, minus 3 times equation 1 is x minus y plus 3z equals to 8. So you get minus 3x plus 3y minus 9z equals to minus 24. Now we write the equation 2, which is 3x plus y minus 2z equal to minus 2. If you add, minus 3 and 3x cancel out, and 3y plus y becomes 4y minus 9z and minus 2z. When you add, it becomes negative 11z, minus 24, and minus 2 becomes minus 26. So let's solve this for y. Divide this both sides of the equation by 4. So 4y divided by 4 is equal to y, and then minus 11z by 4, and then minus 26 over z. So minus 26 over z becomes minus 13 over 2. So we have y minus 11z, 11 over 4z equal to minus 13 over 2. So we can call this as equation 2 prime, another new equation 2. Now we eliminate 2x in equation 3, and we multiply again the equation 1 by negative 2. and then add into equation 3. So here we have minus 2 times equation 1 minus 2 times equation 1 is x minus y plus 3z equals to 8. And this yields minus 2x plus 2y minus 6z equals to minus 16. And now we write equation 3, which is 2x plus 4y plus z equals 0. Now if you add, they cancel out, and that's what we want. 2y plus 4y becomes 6y, and minus 6z plus 1z will be negative 5z, and minus 16 plus 0 become minus 16. So this is our new equation 3 prime. So we call it 3 prime. Now we rewrite the new equivalent system of equation just obtained. So now we have x minus y plus 3 is equal to, which is the original equation 1, and y minus 11 over 4z equals minus 13 over 2. That's our equation 2 prime. And then 6y minus 5z equal to minus 16, and that's our equation 3 prime. Now we're going to eliminate 6y using equation 2 prime. So we can multiply equation 2 prime with opposite of 6 is minus 6. So we get this one. Minus 6 times y minus 11, 4z equal to minus 13 over 2. So this yields minus 6 times y minus 6y, minus 6 times minus become plus 6 times 11 over 4, which becomes plus 66 over 4z, and equals to minus 6 times 13. So we minus times minus plus 78 over 2. Now we can simplify it. We can have a minus 6y. Now we can add this into equation 3. So equation 3 is 3 prime, 6y minus 5z equals to minus 16. So minus 6y plus 6y, they cancel out, and you have 66 over 4z, and we add into or subtract 5z, and then we 39 minus 16. So becomes 23, and we can have to combine these two. So we convert 5z into 24 over z. So multiplying 4 on the top, 4 on the bottom. So now we have 66 4 over 4z, and this has become negative 20 over 4z equals 23. Now we can same denominators like fraction, so we can subtract the numerator. 66 minus 20 becomes 46 over 4z equals to 23. So now we can get rid of 46 over 4. We multiply the reciprocal of 46 over 4, which is 4 over 46 both sides. So now we have 4 over 46 times 46 over 4z equals 4 over 46 times 23. So you can 4 cancel, 46 cancel, we get z, and 23 times 4 is 92 over 46, which is 2. So now we have we rewrite equation 1, x minus y plus 3z equal to 8, and y minus 11 over 4z equal to minus 13 over 2, and we just got z equals 2. Now if you notice, the leading coefficient is 1, so that now this system is row echelon form. So now once the row echelon form, we already found the value of z. Now we do the back substitution. So we substitute z is equal to 2 in the previous equation. So now we have y minus 11 over 4, where z is 2 now, equal to minus 13 over 2. So let's simplify. 11 times 2, 22 over 4, y minus, you minus 13 over 2. Now we can move the minus 22 over 4 to the right side. So it becomes y equals to 22 over 4 minus 13 over 2. So in order to subtract We can simplify 22 over 4 becomes 11 over 2, and you have minus 13 over 2. Now same denominator, so we can subtract 11 minus 13 is negative 2 over 2, which cancels to negative 1. So y is now negative 1. We already know z equal to, we just found y equals to negative 1. Now we're going, so now we substitute negative 1 for y and 2 for z in equation 1. X minus 5 plus 3z equals to 8. So we get this x minus and y we change to negative 1, so we negative 1 plus 3 and z we change to 2 and equals to 8. Now we simplify, so we become x plus 1 and 3 times 2 is 6, 6 plus 1 is 7, so we x plus 7 equal to 8, move the 7 to the right, and we become x equal to 8 minus 7, which is 1. So now we write the solution, the x is 1, y is negative 1, and z is 2. What is non-square system? A system of linear equation is non-square system if either of the following is true. The number of equations are less than the number of variables, or the number of equations are more than the number of variables. The non-square system does not have a unique solution. It has infinitely many solutions. So let's do example 4. Solve the system of linear equations. We have x minus 3y plus 2z equals to 18. 5x minus 13y plus 12z equals to 80. Now there are only two equations and there are three variables. So there are less equations, the more variables. So this is an example of a non-squared system. So step 1 is make sure these equations are in standard form. And x minus 3y plus 2 is equal to 18 in standard form because all the variable terms on the left side and the right side is a constant. So we can call this equation number 1. Similarly, second equation 5x minus 13y plus 12z equals to 80 is also in standard form because all the variable terms on the left side. So step 2, rewrite the system in row echelon form. So note that the leading coefficient in equation 1 is 1. And so I begin by keeping the x term in the upper left corner, this upper left corner, and eliminate the other x term, like 5x from the first column, the second equation. To eliminate 5x using equation 1, we multiply equation 1 by negative 5 and then add into equation 2. So, okay, so we have a negative 5 times equation 1. So negative 5, the equation 1 is x minus 3y plus 2z equals to 18. So this becomes negative 5x plus 15y minus 10z equal to minus 19. Now we write the equation 2, 5x minus 13y plus 12z equals to 80. So let's see if we add the cancels. 15y minus 13y becomes 2y, minus 10z plus 12z becomes 2z, minus 90 plus 80 becomes minus 10. And now you can notice we can divide by 2. So you divide by 2, we have 2y over 2 plus 2z over 2 equals minus 10 over 2. So it simplifies to y plus z equal to minus 5. So now we rewrite the new equivalent system of equation just obtained. X minus 3y plus 2z equals to 18, equation number 1. And equation 2 has been changed to y plus z equal to negative 5. So therefore we can go. So now what we do? We can let z is equal to some number. So let z is equal to a. A is any number, real number. So now you can see that the leading coefficient of this term, and this, they're all ones. So you can consider this is a system of equations in row echelon form. So now we can do back substitution. So we substitute z is equal to a in the previous equation. We have this y plus z becomes a equal to minus 5. Now we can move the a to the right side as negative a, so we have y equals to negative a minus 5. So now we substitute negative a minus 5 for y and a for z in equation number 1. So the equation 1 becomes x minus 3, y changes to negative a minus 5, and plus 2, and z changes to a. We distribute negative 3, we have x plus 3a, and become 15, plus 2a equals to 18. We simplify, so it becomes x plus 5a plus 15 equals to 18. Now we move the 5a plus 15 to the right side, and we have x equal to 18 minus 5a minus 15. Now 18 minus 15 is 3, so we have 3 minus 5a. Let's rewrite. First we write the negative 5a and then plus 3. So now we have formed x equals to negative 5a plus 3, y equals to negative a minus 5, and z we'll add it a. Now we write this as x is negative 5a plus 3, y is minus a minus 5, and z is a. So this is triple is our solution.